look at this LED here. It brighten up slowly and then fading away slowly. Brighten up again, fading away again. Brighten up again and fading away again. It is not like in the previous lecture where the LED is directly turned on and turned off, but instead it brighten up slowly and then fading away also slowly. So how we can do this? So to do this, we will use a function called Pulse Width Modulation, or PWM, which is a technique for getting analog results with digital means. In other words, we will convert, or we will change the values of the digital output so that it can give not only high or low values only, since we know the digital output is only giving high or low values only, 5 or 0 volts only. But now by using this pulse width modulation technique, we can change, or we can get the output of the digital outputs with several different range of value, not only 5 volts to 0 volts, but the other volts in between. This is done by changing the width, or modulate the width of the pulse. That's why the name is pulse width modulation. For example, as you can see here, this is one example of pulse that comes out from the digital outputs of the Arduino. So this is the pulse width here. This is pulse width at 100%. So we can change this pulse width into the lower value, like this, 75% only the width compared to the last time at 100% for each period of each cycles. And then 50% we can reduce it further to 25% and further down until it reaches 0%, which it will only give 0 voltage for the whole periods of the cycles. So this is what we call the pulse width modulation. We change this width here, and this width here is what we call the periods when it is turned on, and this parts here we call as the periods when it is turned off, or T on and T off. And this is the total period of one cycle. So to know the duty cycle of this pulse, we can simply get the duty cycle, which is equals to cycle, which is equals to the T on, the period of it is turned on, over with the period of the one cycle, T on plus T off. This is the duty cycle. So that is to get to know the duty cycle. And if we want to know this percentage value here, when it is turned on here, so we can just simply change this duty cycle value to the percentage value, which is by times with the, in percentage, by using equals to T on over T off plus T on for the total period times with the 100%. So we will get the duty cycle, as simple as that. So that is how you get the duty cycle percentage. So why we need this percentage value? Because this percentage value that will be converted into the voltage, the output voltage later on, which the output voltage will equals to this duty cycle in percentage times with the 5 volts. So duty cycle in percentage times with the 5 volts, because the output, the total output is 5 volts. Now the maximum output is 5 volts. In other words, we can get, instead of the output is just 0 or 5 volts like in the chapter 1 before, so instead of we only get 0 and 5 volts at the output, but what we can get by using this, if we have the 100% of duty cycle, it will come out with 5 volts. And if the duty cycle, this is the duty cycle, so if this duty cycle is 0%, so it will be, the output will be 0 volt. And if it is at 50%, so the output will be the 50% of 5 volts is 2.5 volts, and so on. So we can get, for example, 75% duty cycle, so we can get 3.75 percent, 3.75 volts. Okay, so 3.75 volts. So in other words, we can get many range of voltage output, which then can be since the output is changing one by one, and the output have different value, different range of voltages. That's why we can see at the LED just now, it lighting up slowly, it brighten up slowly instead of just directly turn off or directly turn on, but it just going slowly until it reach the maximum, which is 5 volt. It reach the maximum intensity, and then it drop down again. It fading away again from the 5 volts, and then it goes to 4 volts, 4.5, 3.5, 2, 2.5, and so on until it reach 0 volt, which is it finally turn off. And this is how we change the duty cycle, or how we change the intensity of the lights, LED lights, or we change the values of the output voltage. So that is the basic concept of pulse width modulation, PWM. So now we can start to assemble our circuits. So before this, you have already assembled an LED circuits with resistor, and now you just need to reuse the same circuit, but make sure you connect to the this output here. Either of this output, but the one that I show you here is using the 11 pins, the pins 11. So why pins 11? So as you can see here, this part here, pin 11, pin 10, pin 9, pin 6, pin 5, and pin 3 has this wavy symbols here, the wavy symbols here. So this wavy symbols what means the as a symbol for the PWM. So meaning that if you want to change, or you want to use different values of the output, display different values of the output, you must use these curly signs only. Don't use the pin 8, don't use pin 7, don't use pin 12. These are only giving you only 5 or 0. Only these 6 outputs only that give you this range of PWM that you can manipulate. So that is the terminals or the outputs that you can use, the output ports that you can use. But in this example, if you want to directly follow this example, you can just use pin 11 as well. This is if you have hardware. So if you have hardware, you can follow these circuits here and try to assemble it first. If you don't have the circuit yet, but actually you can just directly edit from the previous lecture. But if you need time, then you can pause this video and assemble this circuit first before you proceed with the next one. But if you don't have hardware, as usual, open up your Pro Tools and assemble the circuit. Again, similar like in the Tinkercad just now, it used pin 11. So just use this circuits. If you have the previous circuit which connected to pin 13, then you will change the lines here to the pin 11. Now if you need time, again you can pause this video first before we proceed with the programming. So if you have complete your circuit, now you can start open your Arduino IDE, and now we can start coding. So as usual, the first steps to code here, from this coding, now I show you one by one the coding instead of we just run. Basically you can just run from the example here. You can find the example of the fading, which is using the PWM, but I want to show you the one by one the coding. So let's go one by one. Try to follow my example here. Yeah, so as previously I have also already mentioned that first we need to tell the pins, which pins we use, and what kind of pins it is. Either it is output, or the mode it is, whether it is output or it is input. So now we set the pin mode. Just now we use the pin 13, pin 11 here, as you can see. So since it is using pin 11, so now we add 11 there and as output. So this pin 11 will become output. So this is the pin for the LED. But one tips for you. Let's say you have a lot of LED with different colors, or a lot of outputs with different things, so you might confuse which pins is the LED, which pins is LCD, which pins is what output, which pins is what display, and so on. And therefore, instead of you use pin 11 here, we can before this void setup, we can actually define some variable here, one variable or one constant variable. For example, like this one here, we initialize this pin 11 as pin LED, because we have one only single LED. Let's say if you use a different LED, so you might need to use to say this as LED red, LED blue, LED green, for example. So now I just write here as LED at pin 11, which means that if I want to make sure I'm not do a mistake on identifying which pins, so I just write here the pin LED is output. So which means since LED I already defined as 11, meaning that here it will find the pin 11 as output. Simple. So this is one tips. If you have a lot of pins or a lot of outputs, a lot of things inside your circuit, whether input or output, so if you don't want to mess up, or you don't want to confuse later, so the best thing is you define it here before the void setup, because this is a global variable which will be used in every functions here. Not only one function. If you define it inside the void setup, it will only be able to use in the void setup function only, and that's why we define it at this parts here before the void setup, or outside of each of the function here. Okay, so now after we already setting up our pins, the mode of the pins, we already tell which pins we want to operate, or which output ports that we want to operate. Now we can start program the loop functions. So now we want to make it increasing. The brightness is increasing slowly from 0 until it reach the maximum values. So this we add one by one the values, from 0 up until the maximum values, so it will brighten up slowly. In other words, we can use this loop, one more loop here. This is what we call a for loop, for example, which, let's say we just define as I, the brightness is I, which start with the 0. Again, it is turned off first, and then semicolon, we will increase the value until it reach maximum. So meaning that it will keep increasing until the maximum. What is the maximum value? The PWM will give 8 bits. The PWM will give 8 bits value. So the PWM will give 8 bits. So again, to get how many value for this PWM, how many data is stored in this PWM, we can just use 2 power of 8. So 8 is 8 bit, 2 power of 8, we get 256 data. So in other words, these lines here These duty cycles here from 0 until 100%, meaning that there are 256 data. So in other words, it is until 255. Why 255? Because 0 is also one data. So 255 plus 0 or plus one more data here is 256. That's why we have up to maximum 255, because the total here will be 256 data. So in other words, between this have 256 data between this, which 255 will be converted into 5 volts, and any value in between it will be converted into each respective voltage. So that's why again what we will see here, the maximum value will be before the 256. As long as it is not reaching 256, we will keep increasing one by one, the value one by one. So which means I will increase one by one, increase by one, I plus one, or the easier way, I plus plus. So it will keep increasing until the maximum value. When the maximum value reach, it will come out from this for loop, as simple as that. So now here is the loop that we will use. What will be in this loop? What will be in this loop is we will, since as long as it is in this value, it will give the value, or it will output the value, this value here on our LED, which means we want to write this data on the LED, but we can't. Before this, we use digital write. Digital write. Remember, don't forget that these lines here is case sensitive, which means don't use everything low small letter. If you use small letter, it cannot recognize, so you must follow 100% how to write this code, because it is a case sensitive. So before this, we use digital write. Digital write only give high or low only. It cannot give any value between 5 volts. So the only way to give different values, the only data that can give different range of data is analog data, and because of that we use here as analog write instead of digital write. So the analog write would write the pins, the output pins, which is the LED, the pin 11, because we already have defined the pin 11 as LED before, so we can use here as LED, with the value of the incremental value from 0 until to 255, which means the value here is that it will write is I. So it will write the LED values by using the values I. The values I will keep increasing from 0 until 255. So that's it. And it will write one by one. Since we want to make sure it is not too fast, so we put a delay here so that it wait for a second, for a few milliseconds before it goes to the next value. Therefore the delay here, like for example, we can put maybe 10. If you want to make it fast, you can just try on your own. Any value is acceptable. If you put higher, so it will the delay will be higher. It will become more slower, because again this value here is in milliseconds, so we just wait in 10 milliseconds only, or 0.01 second. So this is after we wait for a while for 10 milliseconds, then it will continue. We will loop again, loop again, loop again. It will increase the value again and again until it reach to 155. So that is how we increase the value, and when it reach the maximum, then it will come out from this loop here. So that is one way to, this is how you increase these values here, how you increase the brightness of the LED. So now we can check this code first before we proceed with the next part. So as usual, if you want to check the code first, you can click verify. So when you click verify, it will ask you to save the coding. So just save the coding, whatever name that you want to use. So now it will verify, compiling sketch, done compiling, no problem, no error. So now since no error, we can load it into our hardware. So if we want to load it into our hardware, so what we can do next is, after we connect with the hardware, now we check again. Don't forget to check that it is the correct Arduino boards, because there are a lot of Arduino. So make sure it is correct with the Arduino Uno, and then make sure it is at the correct communication ports, the common number here. So for example, now I am at the COM4, and after that we can upload it into our Arduino. So just wait until it done uploading, and now we can see it. So okay, so as you can see here, now it brighten up slowly, and then it come out from the loop, and then it start to brighten up again from 0 until maximum, and then it directly turn off. So we don't want this actually. Before this, the example shows it will brighten up slowly, and it will fading out slowly as well. So in other words, it's not brighten up and then directly stop, brighten up directly go down. No, we want to brighten it up slowly, and then it will fading down slowly as well. So how to do this? Now we need to add a few more lines of code in our Arduino, which we add another for loop here. So this for loop here is to fading out, which means that the first value here is the maximum value, 5 volts, and then it will reduce until it reaches 0, which means that as long as it is greater or it is greater or equals to 0, it will keep on fading out. So when it keep on fading out, meaning that we will reduce the value one by one, reduce the value one by one, I minus 1 or I minus minus. Simple. So the same thing, we will rewrite the LED value by using this I value here. As simple as that, until it reaches 0. So now when it reach maximum value, it will go to this loop until it reaches 0, then it will go back to the for loop again, because now it start with 0 until it reach maximum again. So it should comes out from 0, turn off, and then brighten up until maximum, and then at the maximum it will fading out until it reach 0 again. So now let's test it again, upload it. After you have upload, now you can see it brighten up and then fading away, brighten up again, fading away, brighten up again and fading away. So now we get what we want. So this is how you use PWM, as simple as that. So you can use it in many of the functions, many of things. For example, for if you want to control motor speed, because the motor, if you want to turn the motor around, or because it is too fast, because you want to slow it down, or you want to change any values. So this is how you use it, by using this pulse width modulation technique. So the basic is here, so you can play around with it, so in any forms, so that you can more familiarize with this techniques. So what I just showed to you is by using the hardware. So as usual, if you don't have hardware, so find again the hex file down here. So search for the hex file. If it does not come out like this, as usual, go to the file, this is as a reminder, preference, and click check the compilation, but since I have already showed this in the previous lecture, so now let's just copy this hex file here. So this is the hex file, so copy this hex file here, Ctrl C again, and paste it in our Arduino here, double click it, so now paste it. Okay, so now this should be able to run, so click run, and when you see the output from the Proteus, it shows like a blinking like this, instead of fading out and fading, instead of brighten up and fading away. So it will shows blinking until it brightens at the maximum value, and then it will start to blinking again until it fully turn off. So this is not the actual representations of the real hardware, and that's why the best thing, like I've said, you still need your hardware for this. And if you feel not satisfied with this simulation, you can also copy and paste your coding and simulate in this Tinkercad here. So copy and paste your code here in the code section, and then start run the simulation, and as you can see, it brighten up slowly and fading down slowly, brighten up and fading down. So that's it. But as you can see, both simulation does not be able to show a very nice real solution views. That's why I really suggest you to get the hardware. If you don't have it, try to invest a little bit again, so that you can really see the brightening, the LED brighten up and fading away, and you will appreciate the knowledge that you get. And I think that's it for the for this parts here, the pulse width modulation parts here. Hope you understand my explanation in this video. So if you have any problems, as usual, feel free to ask me. I will be more than happy to help you. And again, don't be shy. And as usual, stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.